this meeting. Hope that's okay with everybody. All right, it's 3 o'clock, and thank you for attending another ESIP Interoperability and Technology webinar, Tech Dive webinar. This is the Interoperability and Technology, IT&I, as we call it, committee page here on the ESIP Fed site. I just want to remind folks that if they want to get on the mailing list to hear more of these kind of talks, you can click this join button here, and I've also chatted that link into the chat for this meeting. So we also record each meeting. The list of meetings, if we go here, we can see this the list of all the meetings that we have had, and usually we have at least the next talk scheduled. The next talk will be the 10th of November. It's the second. We meet on the second Thursday of each month. I'm actually looking for someone to talk about vector tiles, and I haven't lined up a speaker yet. So if anybody knows of a good speaker for to talk about vector tiles, I'm trying to get somebody from Mapbox, but they haven't committed yet. Anyway, so you can, the previous talks you can see here, and they're all recorded, and usually we have the slides. And this week we have Phil Yang from GMU talking about EarthCube integration and test environment, this ECITE environment. So I'm going to turn it over to Phil, and let's see, I'll make you the presenter, Phil. And okay, so you should have the ball, and you should be able to just share your screen. You looking good?
Yeah. Did you see my screen?
Yes, it looks good.
Okay, great. Let me see. Oh, no. Okay, good.
Do you need to go to present, there you go. Okay, good. Yeah. Looking good.
Yeah. Okay. Well, thank you, Rich. And it's great and an honor to be here with the ESIP Interoperability and Technology Committee and to present the EarthCube integration and testing environment. I'm Phil Yang from George Mason, and this is the EarthCube project. We're present in the ongoing project, the first year results. And this project has this key personnel. Sarah, in fact, from UAH is the PI, the overall PI on this project. And George from Caltech, Emily Law from JPL, and myself from George Mason, and we for the co-PIs and PIs on this project. So as we said, this is a 2-year project funded last year by NSF EarthCube program. Now we're just finishing up the first year and entering into the second year. And the first year is fully funded to develop the prototype, have it in learning status. And the second year we get merit support for the maintenance of the system. But there's more to be developed. So I want to report, based on that status, the background of the ECITE project and what is our objective and what is the platform that we designed and developed and integrated to support this effort, and also what are the progress of this project, and look at some of the user interfaces. And if you're interested, you can take a look at our system or look at YouTube user guide. So we have some videos made about how to use the system. And also we're using the open science framework to facilitate the evaluation as a framework. And then I'll talk a little bit on what is the next step that we're planning. So first, the background. The history of this project really comes from EarthCube needs the place that we can create a place to hold the identify and support the creation of interoperable tools and also services for geoscience research. And as we know, the challenge of interoperability really it's across separate projects. Without a common infrastructure and environment, it's very hard to test or to integrate. So this is one of the challenges we're addressing with this project. And through the EarthCube tag survey, over about 2/3 of the participants indicate that we do need an EarthCube testbed to facilitate the common infrastructure and to support the testing of the interoperability and other requirements of EarthCube. And also we had a testbed working group within TAC to evaluate the needs, state of the art, and also make the recommendations. So this project is really a community need to project, and it is with the mind to enable multiple developers to integrate the components, and also we can use that environment to test for compatibility and interoperability. So as an overview of how we address those challenges or requirements from the project perspective, we are integrating a testing environment for EarthCube participation, and it is a collaborative environment for prototyping, integration, and testing, and also could be used for validation and demonstrating and showcasing the project results, different EarthCube projects. And it is for really the EarthCube program-wide INT methodology, testing experimental purpose, and with the collaboration and participation also from different projects within the EarthCube program. And the objective is really to have this project serve or provide an infrastructure for testing and evaluation of the software and the components, capabilities, and services developed from EarthCube projects, and also to foster the integration and interoperability across different projects and different EarthCube assets, and to open easy access computational resource for EarthCube, and to deliver and preserve for funded projects when they're finished and the results is produced. So the approach is really we leverage the cloud computing for this purpose. We created a federated cloud environment which spans across private and public infrastructures with advanced secure connectivity and broad interoperability across the data and infrastructures. So we could address the challenges and issues with multiple domains and system configuration, security concerns, and also the interaction, and extend the central management mode of the initial system to manage a hybrid ECITE infrastructure. After we get into this project, we think back about what are the challenges to deal with. We really found out that this is a challenging spatial temporal problem on several aspects. First, the intersection of the data and the phenomena. The core relation are spatial temporal, which includes the data management and access strategy, and also users, or where are they coming from to access and to identify. And also the research interest are quite different from time to time and from places to places. And there are also some dynamics of the datasets availability part. For example, there may be new datasets come online, or real-time versus long-time static data, how to deal with those problems. So after think out all those, we come up with an approach as a hybrid cloud computing, but with some spatial temporal optimization into this platform. And this is a conceptual design of the platform. Initially, for the prototype side, we have the GMU private cloud resource bursting into the AWS as a public. And on top of both of them, we have some basic virtual machine images, which include some long-time running systems, long-time libraries, and also on top of that, we can support different EarthCube projects. We have several projects running in the environment. And this is the prototype or the current stage. We are in the process of generalize this to have an innovation operation, as you can see from here, in which we can have the cloud as a computing infrastructure, which will have the basic virtual machines, and then we can integrate the capabilities from different projects and have a single sign-on transparent access to the platform to ECITE from different communities within geoscience. For example, the building blocks research correlation networks of EarthCube and also from different domains like ocean science, ecology, atmospheric sciences. So this is the first phase as the prototype we have here, and the second phase is really to implement this innovation in the operation. But for the second phase, we're partially funded, so we're in that process. And this is the participants of the ECITE, the resource. In terms of resource, we have the computing resource from George Mason, and also from Caltech, and SDSC, AWS, Amazon, and also with the Jetstream, which is the NSF ECITE Cloud project, also contribute resource to this effort, and several others. As you can see from this map, it's really almost a nationwide resource. And to be more specific, these are the ones that we have the resource already integrated, and we have them managed through the centralized management process. So currently we have Jetstream, which is an NSF-funded effort, with cloud resource integrated, and also have the hybrid cloud computing environment from George Mason, about 500 load computing cluster from the NSF Spatial Temporal Innovation Center. And also we have several servers being testing at Caltech being added to this effort. And the projects, we're working with them to have them working in an exciting environment, including CODES, BQ, Synergy, and ESIP, and several other projects. And so the management of this is really based on the what we call the Dynamic Computing Cloud DC2 software, which provides the hybrid management to the public cloud like Amazon, but also could manage the OpenStack, Unity based private clouds. And this is a software architecture. We have the DC2 management tool, and the Amazon AWS cloud, and OpenStack private cloud, and Unity private cloud. And they all can be managed in a same fashion through a single sign-on. So there's some major features. I'll just briefly go through this. Could be very detailed. So the resource management is consolidated in this process, and we customize the user account management, which means the users could manage their own projects. They can be on one or multiple projects, and the resources could also be allocated to each of the different projects. And from the computing side, we can scalable and dynamically provision resources, including virtual machines, storage, and others. And also there could be some real-time usage visibility, which means that we can check, see how much resource has been used by my project, so I get a better idea about what more do we need and how much experiments could we still conduct within the current resource. The platform could also support cloud-based HPC. And this is a detailed graph about the network configuration of the George Mason side hybrid cloud. Just quickly go through this. So after talking about all those, this is the process of how to access the cloud environment. First we go to this site to log into the ECITE, and after we log into there, we can have access to these different functionalities, as you can see from here, this menu, which could provide the project management and virtual resource management, network security, and IP cloud and cloud usage and VPC. So these are the screenshots for each of them, how we manage the security side, the project side, the K-pair, and also how to create virtual resources, for example, instances. And we have a specific online user instruction, which you can come here. If you click here, and this has a very detailed instruction about how to use the resource. And if you're interested, you're welcome to take a look at this work page and let us know if you have any questions. And after you stood up the virtual resource, you can come here to monitor what is the usage of each of the project. For example, here we shows how much has been used by the CODES project, how much has been used by the Dasher project. And we also have the modules, which are all integrated into one interface, one single sign-on. So after we sign in as a user of the software of the ECITE environment, we can have management for the AWS resource, as you can see here, the Amazon, and also have access to the Euclidus, which is a private cloud, you can see from here, and also the OpenStack resource. So all three different types of cloud environment can be managed through a centralized management approach. And there are some workflow diagrams about how to create and access the virtual resources. For example, on the left side we have about how to create the virtual instance and how to access the instance. And if you're interested in the details, there's some YouTube movies. If you click on this link on the bottom here, you can see from YouTube. In fact, we loaded this to the YouTube. So you can see from here how to create the virtual machine, going through step by step, how to give it a name and select different images, select different virtual machine types, and what kind of KLAM to use, what kind of security group to use, and what is the user we're going to associate that to, and which project will we have that resource. So this is very straightforward, helping end users to be able to operate on the ECITE cloud environment to support the research. So this shows about this has been started. So there's some common functions. Users can use the ECITE interface to create instances in different platforms, AWS, OpenStack, Euclidus for one project, or you can also use the ECITE environment to manage multiple projects which are running in the environment. And you can also create new users and assign the roles within that project as a project manager. So different roles will have different privilege. For example, some of them will be able to create a virtual resource, which really means cost some funding to support the project operation. And some of them may be only accessing those virtual resources so that they can conduct their scientific research. And users can also monitor the cloud resource usage and select the platform and also funding of this. And these are the interface examples again shown here, and this is a resource usage monitoring. So on the project management side, we also adopt the open science framework to do the, this is an example of the evaluation framework. For example, we have been developing several use cases. I don't know if Ken Kaiser from UH is on the call, because he was developing doing this part.
I don't see him on the call, but
okay. So basically, what we could be doing is that we can we use this to manage the ECITE operation. After we have the EarthCube, for example, projects running there, we can design different use cases to test the interoperability, and each of these use cases can be divided into different steps and what needs to be done by each project and then how to integrate them together to do the testing. So if you're interested in this part, you can send an email to Ken, and he's the person really behind this open science framework part for the ECITE project. So this is a plan of the entire ECITE project. We have finished the prototyping, and we identified the artifacts, set up the basic testing environment, and we have several projects from EarthCube program running in the environment. Along with doing some of the validation about the functionality, usability, and affordability and technology of this. And also get a little bit into test environment analysis. This is a part that I showed on the open science framework that Ken is working on. A lot of people have been contributing to this effort. This includes some of them from the EarthCube Testbed Working Group within the TAC, the Technology Architecture Committee. And so in summary, the ECITE prototype is on schedule. We just entered the second year. The project started last year, September. And has been demonstrated at EarthCube All Hands ESIP Summer Meeting. We're planning to do demos also at ESIP Winter Meeting and AGO Meeting. And it provides a basic integration platform and provide initial use cases that involve multiple EarthCube building blocks. Project includes for example, BCube, Untitled, codes, and the current Testbed Working Group has been providing guidance to this project, and a new working group is being considered to be formulated to support this effort. And we always welcome community engagement, and so if any of you are interested in this project and want to know more details, please let us know. You can either send me or any of the PI, co-PI an email, and we'll be in touch with you. And there's some related information. It's all linked here. The EarthCube homepage, you can find the ECITE project homepage is also there, and the Testbed Working Group homepage is also here. So that it's very quick. I know that's a brief report about the ECITE project. At this moment, I'm going to take any questions you may have.
Okay, thank you very much, Phil. So I think some folks on the line, you might check and see if you're muted. If you want to ask a question, obviously unmute yourself. I might just start out with a question. So the idea here is if you're a participant in any EarthCube project, you could request some resources here or get an account.
Yes, that's right. Yeah. In fact, it's not only EarthCube program. Through the ESIP testbed, we already working with the semantics and ontology committee. So if there's any request from the ESIP side, we're also working with you to make that happen.
Okay. And so you mentioned, I think you, like on one of your slides, so the basic idea is most people would probably be working on the private cloud, which is hosted at GMU, and is that running OpenStack?
Yeah, that one is running both OpenStack and Unitas.
Okay, and so yeah, so if you're an EarthCube or I guess an ESIP member and you get a log on here, you create your virtual machine, you choose some image to run on one of these on your private cloud. Do you have to request a certain amount of resources there on your private cloud, or how does that all work? I mean, I assume George Mason are they subsidizing this, or is this all paid for, by EarthCube to George Mason for the private cloud? I'm just kind of curious how the resourcing works, and how much resources could one investigator ask for, or maybe you're not saturated yet, so it's not an issue, but maybe you must have thought about all that stuff.
Well, yeah, thank you. There's several questions embedded over there. So, but those are very good. In fact, we get a lot of those questions most of the presentations, so that's really good. And yes, there are resources available to us from both AWS and the private cloud. In the private cloud, we have the OpenStack and the Unitas at GMU, and also that is supported at Caltech, and the NSF ECITE JetStream project also provide the OpenStack virtual resource. So you can apply to use any of them, and the cost of this for the AWS, it's been subsidized by the NSF ECITE project, and we have some small budget over there to support this. And for the private cloud side, it's been taken care of by the hosting, the environment hosting institution. For example, in our case at Mason, it's been taken care of by George Mason. Another question regarding how much resource you can request. At this moment, we didn't put out a cap on that yet because we don't have a lot of usage. Among the 500 computing nodes, we're not using them to their full capacity yet. So if you want more, like even for HPC testing experiments, just let us know. If we have a limitation on that, we'll let you know if we cannot satisfy the requirements, but we are trying our best.
That's actually, I think that's pretty exciting. I'll let somebody else ask a question after this, but I noticed that you, quickly again on one of your slides, you have InfiniBand, at least at GMU, and that's like that's kind of essential for like a lot of our ocean and atmospheric modeling, you know, so, and that's usually, you don't get that at AWS. So that would be quite attractive, I think, for some kind of integrated modeling, like, you know, testing the concept of actually doing the modeling and storing the data and actually doing the analysis all on the cloud, you know, not moving any data in and out of the cloud, you know. That sort of research paradigm that we think is coming in the future, but, you know, haven't really fleshed out yet or haven't tested out too much.
Well, yeah, that's a good comment. In fact, it's about how to run HPC jobs on the cloud. Yeah, the InfiniBand helps a lot because the final network speed between virtual machines we could support is about 12 gig BPS.
Mm-hmm.
That has been taking out all the overheads and others. So that's pretty good. In fact, for supporting modeling purpose.
Cool. Somebody else want to ask a question? And again, you may need to unmute yourself.
Hi, Phil. This is Leslie Shi from the USGS. Thanks for your presentation. I just had a question about, you mentioned that some of the projects like Chords and Ontosoft are currently some of the tests. And I'm wondering if the results of their technology assessment, how will the other projects in EarthCube be able to see and maybe learn from or benefit from these initial tests?
Thank you, Les. That's a very good question. We're still in the process of discussing that. In fact, we do not have a comprehensive report for each of the project yet. But that is something that we're discussing among the ECITE project PIs, and also that has to be in discussion with the EarthCube project PIs. So once we figure out that, we will put out some message to the community. But thank you for asking. Yeah, that's in fact a critical element for the success of the project.
Thanks. Yes, I think a lot of people will be interested. Some of the projects that were not in this initial phase, but they have some small applications and they're not really sure how to do an assessment or how to make it sustainable or what the best practices are. This would all be very useful. Thanks.
Thank you.
Other questions? Well, I have another question. I'm wondering, I don't know that much about the different cloud architectures, and I guess you know, I was at Unidata a week ago or so, and they were talking about how, like, their Threads data server, if it's on Amazon, if it's on the cloud, that the cloud, you know, has different ways of moving information around, and that the sort of file-based paradigm is maybe not the
create your own professional website.
Uh-oh.
Hundreds of, whether you're small.
All right, I muted everybody. Let's see, where was I? Oh yeah, so
Change your text.
oh no. Phil, is that you? Somehow that, no. Huh. It's very strange. Okay. Well, I'm wondering if the private cloud instances that are not AWS that you have as part of this ECITE, whether there's sort of special considerations you have to take like that, like moving data from S3 or whatever, or can you just sort of treat them like regular, you know, file-based, you know, just do your work that way, the way we usually do, except on a cloud resource?
Sorry, Rich, could you repeat that question again? Yeah, I was dealing with that problem on my computer. I think it's my browser. That's the problem.
Okay. Yeah, so the question is, I understood from some folks at Unidata a couple of weeks ago, I guess, were talking about how when you put things like the Threads data server or these other, you know, some of the other services that we like to use to serve data, you know, to try to promote interoperability, when you put them on the cloud, they were designed for sort of file-based access, you know, and that the cloud, AWS doesn't necessarily work that way with, I guess, you know, requesting data from S3 or whatever. I mean, I'm not really, I don't know exactly the details here, but I'm asking, I guess I'm asking, does the private cloud also have those kind of issues where we might have to rethink the way that some of our fundamental tools are architected, or can we treat some of those resources just the way we treat our, you know, local machines, but just that they're bigger and, you know, scalable, and you can spin them up and take them down more easily, and you know, be doing that on the cloud. So I guess let me try to make that a shorter question. Do the private cloud instances that you have here in ECITE, do they require sort of rethinking how we access the data that we put on them, or is it just, can we just treat them like file-based, you know, regular file-based systems? Did that make sense?
Yes, that's a very good question. In fact, I would probably split that into two questions. One is that how to allocate or put in the software or the tools into the cloud. Another part is how the virtual machines or the software tools could access the data sets.
Yeah.
So when we put the software and tools into the cloud, there are two ways. One is that if those software tools that you can use is pretty rudimentary, which means it's commonly used, and we may have it already in the image created in the cloud. In fact, from the DC2 management, we could leverage about 60,000 images that's available from the AWS public cloud. So those images are available to us. And if you have some specialized software which may not be installed, for example, if it's some software that you developed, and you need to install that software onto the virtual machine that you stood up. And also there's a technology to facilitate that process. In fact, for the testbed purpose, we may use that a lot in the future, is the Docker container. So once we have the software installed, configured on a virtual machine, we can save that into the Docker, and then next time when we need that, we just spin off, and that can be shared with others with the same software configuration, the same security. So the basic environment side is taken care of using that approach. And so the second question on the data side, there are two or several ways. One is that if it's a small amount of data sets, or if the data volume is not exceeding the storage size, you can just put all the data sets into the virtual machine. So those are like in you're accessing the data from the local disk, from the file path, and you get the data sets. And sometimes we may need the data sets which is not available beforehand. So what we need to do, like those real-time data sets, we may need to ingest those data sets from online. For both the private cloud and the public cloud, we do have all the virtual machines, the capability to access the internet. So both ways are doable. You can either upload the data sets onto the virtual machine before you do the model simulation or doing your data analytics, or you could access the data sets from your own server or from an online real-time resource while you are doing the data analytics.
Oh, right, because I guess you don't have the same on the public cloud. You try to, we're always trying to avoid moving data in and out of the cloud, right? Because then we have to pay more. But I guess yeah, on your private cloud, we don't have that issue.
Yes, the bottom line is that I guess that's advantage is that we don't charge anything at this moment.
Right. that is an advantage.
Bill, this is Ethan Davis. I just wanted to add, I think the question you were asking, Rich, about file-based access to data files by current technologies. The issue isn't that they can't perform in the cloud, it's that they can't take advantage of new types of storage that are available in cloud environments, like S3 object stores and that kind of thing. And they act differently than files. So you have to, and that's, those newer technologies are how the cloud scales, one of the ways that the cloud really scales the huge data. And to really take advantage of that, you have to rethink some software packages and how they interact with the data that's available.
Oh, okay, thanks, Ethan. That makes more sense.
Okay.
So do you have like equivalent of S3 and stuff like that on these private clouds?
Yes, we do have that in the Yucca cloud and also in the OpenStack equivalent to that.
Okay.
So in fact, this needs to, one of the things we talked about earlier, about what kind of requirements may not be satisfied based on the data volume that you're going to run over there. For example, if you have several hundreds of gigabytes of data sets, that's fine. Probably 1 terabyte or 2 terabytes is fine. But if you tell us that you want put up 1 petabyte of data sets, we can't. We don't have that kind of storage. So that is one of the limitations when we look at the request for computing resource.
Okay. So I saw that Ken joined the call. Maybe since we have some time, would it? I didn't really understand that part of the presentation that you were hoping to kick over to Ken.
Yeah.
Maybe Ken could just say a few words about it.
So Ken, when we were talking about the use cases and how the open science framework could be utilized to facilitate the management of the use case and the testbed environment, I was trying to see if you're online. And since you're online now, it'll be great if you can talk to that.
Yeah, so we're kind of trying to model this a little bit after some of the work that was done in ESIP testbed. In fact, I think this was done primarily for the NASA AIST effort to evaluate the technology readiness of some of the projects for that NASA program, and they used this open science framework for that effort. We're also using the OSF, but structuring things a little bit differently for the EarthCube activities. The question before from someone was, how would the public and community see the results of some of the assessments of the technologies? And as Phil was saying, that the policies for that haven't really been realized yet. And that's still kind of an architectural issue that EarthCube is working through, is how to, one, what criteria is that they're going to be interested in for integration and interoperability with other EarthCube technologies and projects, but also how they're going to represent that a technology that's funded by EarthCube has been assessed and found to be EarthCube compatible or EarthCube certified, whatever the terminology is going to end up being. So that part is kind of unknown yet. But what we're doing in ECITE is trying to lay the groundwork, or the framework, if you would, of how those assessments will be done. So we're kind of in the process of now of identifying some characteristic science use cases, and there's a group within EarthCube that's gone to a lot of work of collecting a lot of science use cases from the EarthCube community. And we're trying to marry a few of those up with existing or maybe future EarthCube funded technology efforts. And so the merger or the crosswalk between those then is to come up with a assessment use case, I guess would be a term, that kind of marries the science and the technology aspects that, so using the science use case to exercise and the EarthCube technology to determine if it's meeting the interoperability and integration aspects that we're looking for. A lot of that's still real up in the air yet because, like I said, the architecture group has not really defined all those policies and criteria they're looking for at this point. So we're kind of surging ahead at this point just with some assumptions of things that we think will probably be the type of criteria they're looking for, but all that needs to be formalized yet and kind of put in place. But that's kind of where the assessment activity is moving towards. And of course, with what Phil was showing with the cloud resources through the ECITE DC2 implementation, that will be an option at least for the assessment projects to be able to use those resources to host their technologies and to demonstrate things. So that's kind of where we're at.
All right, thanks, Ken.
This is Amy Burgess, just a quick question. So for the ECITE platform, I mean, at this point it sounds like you're not requiring projects that have, say they're developing a building block, that they'll have to integrate into ECITE and do some kind of interoperability testing, that this is all, these are resources that are being built with the hopes that people will utilize them to test the interoperability, but it's not something that will be required for if you were funded, say, for example, to test your project. Is that the case?
Yes, that's correct. Yep.
Well, that kind of gets down to the meat of the question, Annie. That's a really good point. At this point, like Phil was saying, at this point it's kind of a volunteer thing, because the projects up to this point have not been mandated that they have to meet a certain level of interoperability or integration with EarthCube, because there's not really an EarthCube thing to meet at this point. But the hope or the expectation is, I think, that eventually that'll work its way into RFPs coming from NSF for EarthCube with a list of criteria that will be expected to be met in some shape or form, depending on what the technology is, right? But that's not there yet. But I think ultimately there will be some level of required assessment.
Do you guys? Oh, sorry.
Oh, go ahead, Rich.
Well, no, I just had a. I'm going to let. Are there any other questions? I just had another specific question, but.
I do have a question that might be quick. This is Leslie again. I was just wondering how you chose the Open Science Framework as the place to do the technology assessments, and if that's working well for you, or if there's things about that platform that you like.
Well, we had looked around at a few, and like I said, we were well aware and had been involved with the ESIP activity that Annie had put together using OSF, and there's a lot of aspects of that framework that's really well suited for, I think, the assessment activity that we're doing. It provides you a way to structure different levels of components for a test or an assessment activity and provide control of who has access to the different levels. For instance, the way we structured it, which Phil didn't go into a lot of those details, but we have kind of the public layer at the top, which talks about, okay, here's the assessment activity, and then maybe the next layer is a specific use case, and the highest level use case information would probably remain to be public. But then as you drill down into that and get down into the details of the test plan and the actual assessment activity, some of that's probably not going to be public, during the assessment effort, because you don't want to necessarily air all the dirty laundry that goes into that activity of evaluating the technologies. A final report then probably would be public at some degree to discuss whether the technology was assessed to be compatible or whatever the end result of that is. But overall, OSF seems to provide the ability to structure things, in that way that made sense, I think.
Thanks a lot.
And it's free, which is always good.
So I guess I have a question, maybe probably for Phil, I guess. So is the, I guess I was talking a while ago with the like some of the members of the EarthCube implementation team. No, what is it called? EarthCube. architecture implementation team or something like that, and about the possibility of using one mechanism for demonstrating interoperability across EarthCube. Services would be constructing Jupyter notebooks that showed solve particular use cases, pulling data across from services or whatever, and doing the analysis visualization in the notebook. And there's always a question of, well, do we want to force people to do this locally, or could we just set up an environment for them to do this kind of, execute these notebooks on the cloud or somewhere? And there's the binder service, which I guess NSF supports, but which is really cool, but it's not, they only have a certain number of slots, and sometimes you try to run your notebook there and it's, not available. So for the EarthCube community, if we, if folks like that idea of, doing these, kind of notebooks that could be reused and shared and stuff that would demonstrate different, how to bring different components together, demonstrate interoperability. Could you use this ECITE resource to run your own binder service, or has somebody already stood up like Jupyter Hub or something where people could log in and have a Python or an R environment that was set up, or one that they could customize to run some of the other, if people started sharing these use cases through notebooks, would that be a place where they could run them? Or, I mean, I guess I could go just do this myself, right? I could just sign up for ECITE and get a machine and install, Docker install Jupyter Hub and configure it, and then start letting people have access to it, or how would that work? Since Jupyter Hub has its own sort of authentication and stuff.
Yeah, that's a very good question. Currently, we don't have that integrated into ECITE yet, but we could, as you said, there are several ways to make it happen. One is that if it's just a few EarthCube participants wants to try it, you can just apply for the resource and try it by yourself. If it's something that we found it's so useful for the entire community, yeah, we could provide some kind of central support from the ECITE project side. But in terms of the technology side, we have no problem of doing that. But on the resource side, I guess, since Ken is here, please tell me if there's anything that you think we should be careful about talking about how to support. From the technology perspective, I think it's not a problem at all. We could. And from the computing resource side, we do have enough to support that effort.
Yeah.
Yeah, I think as Phil said, at the level we're at now, I mean, we're not being stressed on resources yet. So I think it's pretty open at this point of what you might want to do there. As long as GMU is is okay with the approach. I will put a plug in though outside of ECITE even is the NSF Jetstream cloud, which Phil had mentioned earlier. They're really open too. I mean, so it's pretty easy to get an allocation from Jetstream to do science, especially earth science type work as well. And people might want to look into that as well as a possibility.
Is that part of ECITE, or is that separate from ECITE, or?
It falls under the ECITE program, yes.
Okay. All right. Well, any more final questions? If not, thanks very much, Phil and Ken, and that sounds like a really cool environment. I personally am going to go try to jump on it if I can with my ESIP credentials.
Yeah. Thank you.
All right. So everybody, the next talk, we hope it'll be on vector tiles on November 10th. Of course, you'll get an announcement before. I usually try to send out an announcement at least a few days before and then an hour before. So, all right. So thanks very much, everybody, and I'll see you next time.